Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. It's October 9, 2024, and the time is 19:38. That's minus 12, 7:38 p.m. My topic for this evening will be a long video format topic, and this is a continuation of my long video format topic, Analytic Geometry. And I am now on lesson number 16. Okay, let's proceed. The subject matter for tonight will be analytic geometry, lesson number 16. We are now on lesson number 16. We are running smooth. Okay, and the title of the topic will be I will be giving you example problem. This will be the second example problem. So parabola example problem. This is actually number 2 now. Because the last time around, lesson number 16, it is still an example problem on parabola, but this involves transmission lines. Transmission lines act like a parabola. Okay, let's proceed. Problem. Okay, I will try to read the problem. The problem is just what I call this, not too long. So find the vertex of a parabola with equation y equal to 2x squared plus 9x minus 12. So what is being asked here is just the vertex with the given coordinates h and k. Okay, the problem is just asking, we will specify the value of h and the value of k if that parabola is given by this equation here. Y equal to 2x squared plus 9x minus 12. What will be the location of the vertex? What is h and what is k? Like this one here. On the last part of the solution, h is actually negative 9 over 4 and k is equal to negative 177 over 8. But we must have to bring out the proper solution of this one to bring out h and k. Okay, let's try to bring out the solution. Solution. We rewrite the given equation y equal to a 2x squared plus 9x minus 12. Okay. Manipulating the equation, we'll put 2x squared and 9x to the left. So they are now to the left. This portion here will go to the left. I will maintain negative 12 on the right. Oh no. Then I will transpose this negative 12 to the left. Then I will try to rearrange. So this y plus 12 actually combined. So this will now be equal to y plus 12. This is no plus because we transpose this one to the left. Then we rearrange. So what comes out is actually 2x squared plus 9x equal to y plus 12. We have done that one to make the left hand side pure x terms, and for the right hand side it will be a combination of y and constants. Okay. If we try to divide all the equations by 2, what will come out will be x squared 9 halves x. The one on the right could be placed in one quantity. So this is multiplied by, if we divide it by 2, it will be 1/2 times the sum of y plus 12. This is quantity y plus 12. And this equation here is similar to this form here. There's a similarity. What's the similarity? The similarity is that the pure x terms is actually the quadratic equation. Quadratic part of the equation. Okay, and the right hand side, it will be just simply a pure constant and a y. So like what I said, this one is similar to the form x minus h quantity square equal to. For the meantime, we do not know the direction of the parabola. Will it be upward or downward? Because for this one here, for one value of y, there will be a value of x to the left and to the right. So it could either be that the parabola will open upward or downward. So for the meantime, I just say similar to the quantity x minus h quantity square equal to a plus or minus 4p times the quantity y minus 3. And the problem is just asking what will be h and what will be k. Okay, let's try to bring out the solution. To bring out the solution of this one, we will be using our knowledge of the so-called completing squares. That's a part of algebra, meaning if we are given a quadratic equation, to find for the pure constant term for that quadratic equation, we must have to use this equation here. That is from the equation ex squared plus bx plus c equal to 0. Okay? This portion here is actually the ratio of b over a. Okay? Then we will square that one. So from the resulting manipulation, the what they call this, the coefficient of x is actually 9/2. So we will take 1/2 of that. Okay, that's the coefficient b over a. Then we will square it. So the one inside the bracket will be 9/4. So this will be 9/4, all quantity square. If we try to square it, it will become 81/16. And what's the significance of this one? The significance of 81/16, the significance is that if we try to add this one to the one on the left, it will become a perfect binomial square. Okay? It is factorable to a binomial thing. Okay? So we will add that 81/16 to both sides. Okay? So this will become x squared, we're just following this, plus 9/2x, plus the computed value 81/16, which emanates from this one, equal to. For the right hand side, I expanded now because this will now become 1/2 y, and 12/2 is actually 6. I separated it, plus 81/16, because actually we add 81/16 to both sides. That's a part of algebra. If you will add something on the left, you will add something also to the right to balance the equation. And after adding 81/16 to the one on the left, like what I said, this is now a perfect binomial. I will remove the 2. This is now a perfect binomial if we put 2 here, quantity square. Because if we try to square this one, what will come out will be this one. And this is factorable to the binomial x plus 9/4 quantity square equal to. For the right hand side, there is a y term and there is a pure constant. So for the meantime, we will maintain the y term. Oh, this is actually 1/2 y, so it's just actually y/2, right? And this one here, this is 6, but this is with the 16, so we will multiply this by 16. We divide this by 16, because 16/16 will be 1, or that's just be simply 6. But we could insert 16 here. And 6 times 16 is 96, plus 81. This is 16 to 16, so we are adding similar fraction. Okay, so it will just be simply the sum of the numerator over a common denominator. So this is 96/8 plus 81/16. And if we try to simplify this one, this y/2 can be written if we try to multiply this by 8 and we try to multiply this by 8. So this will become 16 also, and this 16, right? So this will be 8y, y times 8 is 8y, 2 times 8 will be 16, plus 177/16. We can factor out 8/16, we bring it out. So what remains inside will be y. Okay. For this one, we bring out that 16 here. So this will be divided by 177. This will be 8. Okay. It's just a factorization. After bringing out 8 over 16, what remains is y plus 177. So this will become y. Okay. But this should be divided by 8. And this equation here is actually resembles one of the standard formula of a parabola. Am I still on camera? Of the form, like what I said, this one, x minus h quantity square equal to. Since this is plus, we'll now use the plus. So this is now plus. Right? Or we'll just remove it. It is just understood to be plus. Meaning to say this is plus. Okay? And if we try to recall the, what you call this, characterization of this one, if we try to define it, it's an equation of a parabola, axis parallel to the y-axis, okay, opens, since this is plus, upward. Why parallel to the y-axis? Because for one value of y, there will be two values of x. So the axis is actually parallel to the y-axis. This is parallel to y-axis. So if we now try to compare this equation here and here, we could say that x plus 9 over 4, we will take the value 1 inside. And we will equate that to this, x minus h. So actually this h here cancel with this. But this is minus h. So for this one to be plus, we will multiply all the terms by negative 1. So negative h times negative 1 will be h. And 9 over 4 times negative 1 will be negative 9 over 4. So the value of the abscissa of the coordinates of the vertex is actually at the location negative 9 over 4. Secondly, for the ordinate, we will take this one, we will equate this to this one. So y plus 177 over 8 should be equal to this one, y minus k. Again, this y here cancel with this. But this is negative. We will multiply all this one by negative 1. So negative k times negative 1 will be k. And positive 177 over 8 times negative 1 will be negative 177 over 8. So the value of the ordinate of the vertex is at the location negative 177 over 8. So to specify the coordinates of the vertex, okay, we know h, we know k, the vertex location will be b, open quantity, closed quantity, negative 9 over 4, negative 177 over h. This is h, and this is k. So this will be the answer. The coordinates of the vertex will be at the location negative 9 over 4 and negative 177 over 8, and the figure will be this. Okay? We'll try to bring out the figure. Negative 9 over 4, I divide that by using the calculator. It's almost 2, negative 2. This is more or less negative 2. This is negative 1, negative 2. This is negative 2. Right? That's the ordinate. And 177 over 8 is 22.125, or this is approximately negative 22. So this will be the value of y is actually negative 22. So we will go downwards. The abscissa is negative, the ordinate is negative, so this is negative 22. I counted this one, 2, 4, this is negative 22.125, this one. This link here. Negative 22.125, this is negative 2.25. So this is the vertex. And since the parabola is a positive one, it will opens upward. So it's like this. Actually, the parabola intersects the y-axis at the location 0 and negative 12. It passes here. Actually, even if we try to Find where the parabola intersects the what we call this x-axis. We could find it, but it is not required on the problem. We just figure it out that the parabola, the vertex will be this, and it opens upward. So the equation of this parabola that opens upward with the vertex at the location negative 9/4 and negative 177/8 is this equation here. Okay? It's an interesting problem. Okay, this is Professor David J. De Los Reyes. This will be a good example problem on the concept involving a parabola. Good evening from Los Angeles.